Hello everyone, I am Aman Singh. I'm a PhD student at ISR Mohali. So this is first live session in NPTEL Advanced Linear Algebra course. Here we'll solve some problems related to first week and we'll have live interaction with you. Okay, so actually this part I'm re-recording because of some technical issue. My video was paused, so I'm not going to repeat all the things. Just 45 40 minutes, about 40 minutes, the video was paused and I'm just showing, re-recording that particular session. I'm not going to write it, but yeah, I will review it, what I have done in first 40 minutes. So first we discussed what was topic covered in the first week. Topic covered in the first week. These were introduction to fields, introduction to system of linear equations, introduction to row reduced echelon forms and vector spaces, definition of subspaces and few examples. So we recall what is field. Field was a non-empty set with two operation, binary operations. With plus, a plus was a binary group. F star dot F star means field, means F. We are removing zero, where zero was the identity element of F. With that plus operation, it was group, na? So there was an identity element. So we are removing that identity element, and now it is a multiplicative abelian group. And there is another law for relation between plus and dot, distribution law. It is called distribution law. For any ABC, A dot B plus C is equal to AB dot, sorry, A dot B plus A dot C. Okay. Then these were a few examples which are obvious to verify. We are going to next one. So I define what is system of linear equation. This is some collection of linear equations with some few variables. Here xi's are variable and these aij are entries from field, means scalars. Vi, these bi's are also scalars. Okay. This is particular example of system of linear equation where ABC and these three, this 1 and 4 are real numbers. So they represent line in R2 if it was x-axis and this was y-axis. So this was our first line, which was L. Second line is some ABC. I'm taking parameters. So some line. So what is solution is solution represent points of R2 such that they satisfy this both equation together. So that will be this point. This is called solution. Similarly, if we have n variables, we will get some point x1, x2, x1, which satisfies all these solutions together. Then we say this is a solution of system of linear equation. So here we have three kind of elementary operations. Interchanging of rows, adding two rows, and adding two rows means like first and second row we are adding, and then other equations are left as it is, as they are. Okay. multiplication by non-zero constant. In some equation, if you multiply by some constant, non-zero constant, it doesn't change the solution. If initially x1, x2, xn is satisfying all these equations together, even if you multiply by non-zero constant in some particular equation, I'm not saying you multiply every equation by c. So then also solution is same. Nothing is going to change. So these are called elementary operations. So then I was going to talk about row reduced matrices. So leading term was in any matrix, leading term is first non-zero entry of the row. We say leading term of this row, first row or second row, whatever. This is first non-zero entry in that row. So for row reduced matrices, this is definition. Key leading term should be 1 in every row. If there is non-zero leading term, it should be 1. Every entry below 1 or 0 and up are also 0. Then we say row reduced matrices. Okay. Then I suppose you are all familiar with row reduced echelon form, and we had some, we will have question related to them, some easy stuff. I defined vector space. Vector space is a non-empty set with a plus operation and a star. Star is called scalar multiplication. This is called vector addition. This is a non-empty set. So in general, people say V is a vector space, but there is hidden data. Hidden data is these operations. They matters. Okay. And here also we say vector space over field. Field has its own operations. Okay, they are named here plus 2 plus dot 2, but generally people say let's say V is a vector space over this field. So they do not talk about operations, and it is usually known to everyone what is operation. Is then only they do not care about this. But at this time we should care about this. Okay, P with this operation vector addition, it should be a billion group in a vector space. This property is called defining property of vector space. And what dot means star satisfies, we're going to see in next space. Star is an scalar multiplication, means yeah, it takes an scalar and a vector and it sends sister v, that is another again a vector space. So what dot property star property satisfies? Star means scale multiplication. It satisfies this distributive property, and this is also some kind of distributive property. And 1 star b is equal to b alpha dot, this is field wala dot, beta star b is equal to alpha star beta star b. Okay. Okay. There was, I already told you star is a scalar multiplication which takes an scalar and a vector and it gives some vector denoted by this in V. So this is called closure property, but This is similar to closure property, but if we say star is by scalar multiplication, then it is okay. It is known. Okay. So this was an example R2. R2 plus a star. R2 is pair of ordered pair of real numbers, and these were defining property of what is vector addition, and this is what scalar multiplication. Scalars are from real number because the real number is field. Then R plus was, it is well known, I should say, or you should verify, an abelian group input. This is more generally, this is true that it is a vector space. Verification is left. Then, okay, so here some non-empty set. Someone asked this question, a non what is an abelian group? So abelian group was, I define this, a non-empty set with some operation. I'm calling it this sign plus is an abelian group if A for any A P belonging to S, A plus B is also in S. We say it is closure property of it under plus. This plus is associative operation, means A plus B then plus C is equal to B plus C then plus A, means this. Okay, this you should understand for every A B C in S. And existence of identity, there is a special element E such that E plus A is equal to A is equal to A plus E. Means if you operate E with any element, yeah, okay. This is true for every A in S. For any element of S, nothing changes. It just gives same element A. Okay. And this particular special element is called identity. And this is unique in any available group. One can verify this, but I'm not going to verify. For every A belonging to S, there exists A prime which is depending on A in the same set as such that A plus A prime is equal to A prime plus A, means in either way you get particular element, special element E, then A prime is called inverse of A and vice versa. First four property, if they are satisfied, then it is called group. And the last property, this fifth property, which is for any A and B in S, A plus B is equal to B plus A. If this is verified, then we say it is commutative group or abelian group. Then it S is subset of B such that for every A, B belonging to S, A plus B also belongs to S. S is, let's say, non-empty for defining to be subspace, it should be non-empty subset. A plus B also should be in S. And secondly, this is first property, alpha into A belongs to S for every alpha field. Okay, is this clear? Altogether, these two properties can be combined and said like this: alpha A, alpha star A. Wherever I'm writing, you should understand what I am going to write. Alpha star A plus B is also in S. This is combined property. Okay. Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So, can someone explain why this subset X belonging to R? It is subset of R2, right?
Yes, sir.
I'm writing this subset X axis. Is this a vector space?
Yes, sir.
So, okay. This is, let's say, W1, W2. I'm writing any line. This is a line, right? X axis is a line. Any line contained in R2. Vector space है? Is this a vector subspace? Sorry, vector subspace of R2.
Yes, sir.
Okay, we have. Okay, who is saying no? Can explain. Any line means I'm sub. Let's say, for example, this line. This is our L. Why this is not a vector space?
Sir, because the zero element will not be there.
Correct. Whatever zero of R2 is, zero of R2 means this zero vectors. This origin, we say origin. This should lie in every subspace. So W2 W2 is only, no, I should not write like this. W2 is a subspace only if it pass means this line, it passes through 0 0. Acha, I'm writing this W2 is a subspace only if it passes through origin. Okay, am I correct or not? Tell me if this line is L prime, if it is a vector space, subspace, sorry. Now it is passing through origin 0 0. L is, this is not, this is not subspace. What about this? I'm okay. Let me simplify this. W2 subspace है या नहीं? Now it is passing through 0 0. This is a line passing through 0 0.
Yes, sir.
Okay, ठीक है. This is a subspace. How should I explain? Take any two vectors in this line and add them. You will get in the same line. It its addition will be on the same line. Vector addition means, uh, I suppose you know what vector addition is. Aha. If you multiply by negative numbers, some vector which is in positive direction may go to negative direction. That's all. But they all remains in the same line. So it is closed under its scalar multiplication and vector addition both. So it is a subspace. ठीक है. So I was supposed to do some problems. If anyone has doubt in definitions, these are all definitions I suppose I did. So you can ask. Otherwise, I will move to do some problems. The definitions are clear to everyone, right? From the classes, might
Sir, I have one doubt.
where
So basically, don't understand if row echelon form and row reduced echelon form are the same or different.
see, row echelon form is something less, but if we say reduced, we are where leading term is of course 1, but upside means उस लीडिंग टर्म के ऊपर भी 0 होगा और नीचे भी 0 होगा, then we say it is reduced. Okay.
Can you give any example, please?
Okay, this is example 4 1. I'm writing 1 here. 0 0 0 0 0. This is this is in row echelon form, but not reduced. It is in row echelon form, but not reduced. Reduced means this should become 0. Understood?
Okay, sir. Thank you.
Okay. We say it is reduced if leading term के ऊपर भी 0 होगा, where let's say it is leading term of some row, upside everything is 0, downside is everything 0. Okay, so we are going to next page and do some problems. Here we have a question. System of linear equations are given. So हाँ, आपके लिए मैं इसको मैट्रिक्स फॉर्मेट में लिख सकता हूँ. What is matrix here? 1 1 2 1 1 -1 -1 3 3 -3 3 3 1 2 -7 2 2 -1 1 9 is equal to x1 x2 x3 x4.
-8. Sir, -8.
Okay. I did this mistake to see you if you are listening carefully. Okay, sorry for that. This is -8. Okay, here it is 2, sorry, 3 -2 2 -1. Okay, this is in this format, ax is equal to b. Same system of linear equation is written but in different format. So if we, what question asks, let P denote elementary matrix which replaces second equation by second equation plus 2 times of third equation. Okay, let me change the color. इसको रिप्लेस करना है, मतलब ऐसा करके सेकेंड इक्वेशन प्लस 3 इंटू थर्ड इक्वेशन, राइट. सो इस मैट्रिक्स में क्या होगा, वी वांट टू रिप्लेस दिस रो, मींस वी वांट टू रिप्लेस R2 बाय व्हाट, R2 प्लस 3 times,
Sir, 2 times R3.
2 times third equation.
2 times third equation means here third row basically, correct. So let's see what we can do here. We want to find what this matrix, elementary matrix is. So first let me see 1 0 0 0. Here we have x1 x2 something, let's say x2 and so on. Here we have y1 y2 and so on. If 1 is written here and nothing is written here, so what we get is, if we multiply, we get first equation. What we get is x1 okay. If it is identity matrix, for example, let's say this one, I'm see, this is wrong. little bit wrong. You should tell me first. We are going to apply row reduction, means elementary operation on this matrix A, not on x, y, x1, x2, xn. Okay, so here I should write this matrix A, or something like this: A11, A12, and so on, AMN. If we multiply by identity matrix, identity here it is M cross N. We want to multiply by M cross M matrix. So if we are multiplying by identity matrix, then nothing is going to change. This system of linear equation means this matrix is same matrix. ठीक है? So if we put 1 here, just try this. If we put 1 here, 1. So what it does is, A11 plus A21, correct? In the This is first entry. Here what should be? A12 plus A22, correct? This is just try. So first row is becoming first row plus second row, correct? These two rows are added and putting here in the first row. So just try and error shows us this matrix should be of this format. We want to change our second row, so first row should be same, but in the second row we want second row plus third row, लेकिन third row में 2 को multiply करना है. Everywhere else it is just identity matrix. I'm not looking at variables. How many variables are 5? So it should be 4 cross 5. I think it is good. No.
Sir, last row should be 0, 1.
Last row should be
Last in the last row, last two numbers. 0 first come, 1
here.
and yes.
No. See, we want 4 cross 4, right? This is this matrix is 4 cross 5. So whatever elementary operation we should apply, that should be some matrix E, which is of 4 cross 4. So okay, this is extra.
Okay, sir, I got it.
So this is our matrix E. Then only we can multiply with our matrix A, which is 4 cross 5. If we multiply by E, so first row is nothing is changed. In the second row, when we are multiplying, second row is taken, but 2 times. Third row is also coming. Visible? समझ गया ना ये कैसे हो रहा है?
Yes, sir. Okay.
Okay, so answer should be this matrix: 1 0 0 0 0 1 2 0 0 0 1 0 0 0 0 1. Okay, we are going to next question. So a matrix is given, then matrix B such that A and B are row equivalent. Okay, रो इक्विवेलेंट दिखाने के लिए फर्स्ट ऑफ ऑल थोड़ा सा कुछ रिड्यूस करते हैं, फिर देखते हैं कौन सा इक्विवेलेंट होगा. 1 1 2 1 1 minus 1 minus 1 3 3 minus 3 3 2 1 2 minus 7 2 2 minus 1 1 minus 8. ठीक है. So here we have first entry 1, correct? So
And
we should write it similar, मतलब same, कुछ change नहीं करना है इसमें. But in the second row we should get zero here, all zero, correct? So इसके लिए क्या करेंगे, हम R2 को रिप्लेस करेंगे,
R2 replaced by plus R1, sir.
R2 plus R1, good. Here also it will become 0, but here it will become 5, here 4, here -2. And R3 के लिए क्या करें, R3 should be replaced by R3 minus
3 times minus R3, R1.
R3 minus 3R1, good. So it will become 3 minus 3 equal to 0, 3 minus 3 equal to 0, लेकिन 1 minus 6, it's minus, it should be minus 5, right? 1 minus, we are multiplying by minus 3 here and adding here plus 1. Okay, so if it is 2, it will become minus 3. So 2 minus 3 is equal to minus 1. I suppose answer should be this because this is matching, correct? Okay, let's do one more. Minus 7 minus 3, it will become minus 10. Okay, last one, we want 0 here. We should multiply by minus 2 here and plus 1 here.
Replaced by minus 2 R1.
0, it is minus 1, this is minus 4, correct?
Minus 5.
Minus 5 here, good. Here 1 minus 2 is equal to minus 1, minus 8 minus 2 is minus 10. This, we got this. So अभी इनको करते हैं और कम करते हैं, देखते हैं, अभी मैच नहीं कर रहा, ये गलत हो गया. सो ये वाली रो मैच नहीं कर पाया, गुड. तो आगे चलते हैं. So here we want to get 0 below 5, okay?
Yeah.
Because everywhere
R4,
this entry is
R4,
5 is given, so I don't want to change it, but downside 5 I should get 0. So either A will be option or C. It's like that. So what it will be? 1 1 2 1 1 0 2 5 4 minus 2 0 0. We want to add these two rows. We want to add. So here it will become 0. Here 4 minus 1 is equal to 3 and minus 12 here. Same thing we want to do here also in the third. So it will become 0 here also. 3 minus 12, right? Okay. What is this operation? R3
R2 plus R1, R3 plus R2 plus R3 plus R2, R4 plus R2.
correct. Together these operation will give this matrix, and this is option number C, correct? Because here also we have
Yeah.
0 plus 2 3 plus 1. Okay, this type of question you might have seen in assignment or exercise, whatever you are given. So this is row reduced echelon form of matrix given in A. What was matrix? Oh, okay, we don't want to write this matrix A because this is already in some reduced format like this. So we'll copy it from here. ठीक है?
Yes.
So okay, I had to write. I don't know technology much. So here it was, sorry, what is happening? Here it was 1, 1, 2, 1, 1, 0, 0, 5, 4, minus 2, minus 3 minus 2. Okay. 0, 0, 0, 0, 3 minus 12, 0, 0, 0, 3 minus 12. Okay, this matrix was in already reduced. We already reduced in the second question, but this is not in row echelon form. First, let's say we want to change it to row echelon form. This will become 1, 1, 2, 1, 1, 0, 0. We want 1 here because this is leading term. Correct?
R2 divided by 5.
Correct. So it will become 4 by 5. This is minus 2 by 5. This was 1. Okay. So here this is 0, 0. These two rows are equal. Correct? So last one becomes 0. We will cancel it, whatever we did. Correct? So here it will become 1. Here minus 4.
And minus 4.
Here leading term is 1, leading term is 1, leading term is 1. But everywhere below side it is 0. This is in row echelon form. Row,
Sir, in the last row, what we have did,
last row will become 0 because these two rows are equal.
4, 4 R4 minus R3.
R4 becomes R4 minus R3. Correct. We do first this operation, and then R3 to R3 by 3. Okay. And first we did R2 going to R2 by 5. Okay. Means we are multiplying by 1 by 5. Here 1 by 3. Okay, good. It is in row echelon form. So we want to change it to row reduced echelon form. So what is not good here is this entry. Sorry. Happening. Sorry. So प्रॉब्लम इज विद दिस बिकॉज लीडिंग टर्म के ऊपर जो है नॉन जीरो एंट्री बैठा हुआ है यहाँ हियर आल्सो. ठीक है. सो हाउ टू रिड्यूस देम? I suppose this would be next question. Yeah, next question is this. So let's say we are doing here only 1 1. We want 0 here, correct? So what to do? Let's
So
suppose
R1 is equals to R1 plus 2 times R2
R1
minus 2 times
minus 2 times
R2
R2.
times.
Good. So it will become 0, and here 1 minus 8 by 5, and here 1 plus 4 by 5. Correct?
So
Yes,
minus
sir.
3 by 5 and 9 by 5.
Minus minus becomes plus. Here we have minus
Yes, sir. So I'm saying 9 by 5 and minus 3 by 5 answer.
9 by 5, and this is minus
Minus
3.
3 by 5.
Okay. So here we are good. We get 0 here, good. And here we have 4 by 5 only, and here minus 2 by 5, and here 0 0 0 1 minus 4, and last row is completely 0. So we are going to write it in next page, and we'll get finally row reduced echelon form. Okay. So 1 1 0 minus 3 by 5, 9 by 5, 0 0 1. Here we have 4 by 5 minus 2 by 5. 4 by 5 minus 2 by 5. 0 0 1 minus 4. Okay, so we want 0 here also. Then we are done finally. So what we should do is, I'm not going to write it, but you can see this. R1 is replaced by R1 plus 3 by 5 into R3, and R2 is replaced by R2 plus minus 4 by 5 into R3. Then we'll get this matrix. Let me write. I have already done in past this question. So 1 1 0 0 minus 3 by 5. There may be
So we can
mistakes.
multiply by negative number.
Yeah, yeah. This should be
The
negative.
one of the rules in that abelian group for you cannot multiply by.
Multiplication by minus. Okay,
So we can also write it as R2 minus.
R2 minus here and plus here. You can write here plus. Write here minus.
Ah, sir. Okay. Okay, sir. That's better.
0 0 1 0 14 by 5. 0 0 0 1 4 0 0 0. सो लीडिंग टर्म के नीचे सारा जीरो है यहाँ पर लीडिंग टर्म के ऊपर भी जीरो है, नीचे भी सब जीरो है. गुड. इधर आल्सो जीरो. लीडिंग टर्म के ऊपर भी सब जीरो, नीचे भी सब जीरो. तो ये रिड्यूस्ड फॉर्मेट हो गया. ठीक है. और एक्लन फॉर्म में क्यों है? क्योंकि यहाँ पर k1 क्या है? k1 इक्वल टू 1, k2 इक्वल टू 3 because it is in third column. Leading term is in third column. And k3 is equal to 4 because
4.
correct. And k5
दे दो
k5
खाना कटोरी में दे दो
k4 is equal to
K4 equal to 0.
कैसे?
Only,
1 is not
no,
appearing
no.
here. It should be bigger than. Okay, this is something not to say. Okay, this is because leading term is not appearing here. We should assume that it may appear after some time. If matrix was bigger,
Sir, K3 equals to 4. How it is?
because leading term in third row is in fourth column.
Oh, yes, sir.
So
K1, K2 is a column number.
correct, correct. So K4 is something bigger than 5. Okay, you should assume like this because fourth row में तो कोई leading term है नहीं. So even if it is after fifth column, and after fifth column we do not have fifth column here. So K1 is less than K2, less than K3 because 1 is less than 3, less than 4, less than K4. K4 is something bigger than 5. Okay, so finally we got pro reduced echelon form. किसी को कोई प्रॉब्लम है अभी तक?
No, sir.
Okay. So we are going to see next question. Consider the matrix A from question 2. Same matrix. And X is this and Y is this. System of equation AX equal to Y has a solution provided. So Okay, AXY has a solution. If if last row in A after reduction which is 0 0 0 0 0 last row express equation expression of the sorry equation is not of the form does not take does does not take the form 0x1 plus 0x2 plus 0x5 is equal to some here c non-zero. C for some c non-zero. Other this is violation of the rule. In general, it does not happen. Okay, so in the last row, we are getting after reduction on the left this. So we should get this c. This should imply c is equal to 0. Okay, so we had this equation ax barabar y. Okay, and we applied first row operation. First row operation. In this step, we got some matrix A, let's say A1, A1x is equal to, here also we want to apply same row, first row operation. So it will become y prime. Okay. So what is this row operation? First step. Let's see. In the previous slide we have. While reduction, first step was not here. Here, first step was this. Let's say this is it. Okay, this is first step. Okay. First step was R2 goes to R2 plus R1. R3 goes to R3 plus no, let's see. R3 goes to R3 minus 3R1. R3 minus 3R1. And R4 goes to R4 minus 2R1. So here we got some matrix. I'm not going to write it again. But what y prime become? Initially this was y1, y2, y3, y4. But when we apply first row operation, this y prime becomes what it becomes y1 plus y2, and here third row becomes y3 minus 3 y1. Good. But fourth row becomes y4 minus 2 y1. Okay, good. Now we will apply second row operation. Second row operation. Okay, we need this c, the constant. Okay, in this expression where a x1 xn, here in the fourth place we want 0 because after reduction last row of A becomes 0 0 0 0 0 0 0. So equation becomes 0x1 plus 0x2 plus 0xn. That's it. Okay, so we want 0 here also in the fourth place. Second row operation we can just apply directly. We can just apply directly R4 minus R3. In place of R4 we can replace it by R4 minus R3. Then this row, last row becomes completely 0. And then okay, sorry, what I'm saying is कि now replace R4 by R4 minus R3. Then your system becomes A2x sum A2. I'm not going to write it big matrix, but what y prime become now? Y prime becomes, here it is just y1, here y1 plus y2, here y3 minus 3y1, and here y4 minus 2y1 minus 3 plus 3y1, correct? Okay, and we want this to be 0 because in A2 we see last row becomes 0 0 0, and that will correspond to equation 0x1 plus 0x2 plus 0xn. So same thing should happen here also. That cannot be non-zero. This should be 0. This is your condition we require. Okay, what is this? Let me write it. This was y3, sorry y3. This was 2y1, okay, sorry, y3. So what is this condition? Minus y4 minus 2y1 plus 3y1, yes, and this becomes plus y1 minus y3 minus y3. Okay, this is not minus 4, this was, sorry, see, that was bracket, this bracket. This would be 0, but this is equal to, this implies y4, this is happening if and only actually y4 minus y3, no, y3 minus y4. So option B is correct. Okay, R2 के अंदर वो pairs FB फील्ड ऑफ रियल नंबर्स, एडिशन और मल्टीप्लिकेशन ऐसे डिफाइन हुआ है. See, first coordinate is getting added and second coordinate, whatever it is, we are getting 0. And similarly, scalar multiplication, first coordinate is multiplied by C and second we are getting 0. Which of following is incorrect? क्लोजर प्रॉपर्टी एडिशन के रिस्पेक्ट में होल्ड करता है. ये बिलोंग करेगा R2 में. अगेन नथिंग स्पेशल इज गिवन, बस this is tuple na, this is pair of this form x comma y type, so this belongs to R2. This is also a tuple of this type, so this also belongs to R2. Okay, so closure under addition and scale multiplication holds, तो कोई बात नहीं, this is right. Associativity property holds, क्योंकि associativity होल्ड करता है कोऑर्डिनेट वाइज, वो बाहर भी आ जाएगा. कैसे? अगर यहीं पर A2 B2 लेट से एडेड है, A comma B, okay, why I'm writing here A comma B plus A1 B1, इसको एक साथ जोड़ देते हैं, फिर A2 B2 जोड़ते हैं, A2 comma B2, ये क्या होगा, a प्लस a1 कामा 0 प्लस, ये चीज लिख चुका गया, मतलब दिस इज डन, प्लस a2 b2, what is now a, sorry, a plus a1 comma, sorry, plus a2, this number added to a2, second coordinate already has become 0, this is rule of definition of this plus. Good. But रियल नंबर में एसोसिएटिविटी होल्ड करता है, ये ए और a1 a2 दीज आर रियल नंबर, एंड रियल नंबर तो फील्ड्स हैं, उसके अंदर जो प्लस के रिस्पेक्ट में आर तो अबेलियन ग्रुप होता है, आर फील्ड है, उसके साथ प्लस होता है डॉट में, और प्लस के साथ अबेलियन ग्रुप होता है, तो एसोसिएटिव तो होता है, तो ये अंदर एसोसिएटिविटी लगाएंगे अभी, एंड इट विल बिकम ए प्लस a1 plus a2 comma 0, and now you can calculate this is equal to a comma b plus a1 b1 plus a2 b2. This will become this. तो इस स्टेप में क्या यूज हुआ है, एसोसिएटिविटी ऑफ आर प्लस, राइट, ओके, यहाँ हाफ हो रहा है, तो एसोसिएटिविटी होल्ड करता है, चेक कर लिया, एडिटिव आइडेंटिटी एग्जिस्ट, ओके, ये चेक करना थोड़ा, पहले आइडेंटिटी क्या है वो देखते हैं, ओके, सो लेट्स से a comma b and we are adding something x comma y, we say it is identity if जो भी एडिशन आए वो क्या होना चाहिए, a comma b ही होना चाहिए, करेक्ट, देन वी से कि दिस एलिमेंट इज आइडेंटिटी, राइट, ऐड करने पर कुछ डिफरेंस नहीं होना चाहिए, ए बी शुड बी ए बी, सो बट एडिशन राइट साइड विल बिकम a plus x comma 0, oh problem is here, additive identity does not exist, 1 comma 1 ले लीजिए, what to add x comma y, we should get 1 comma 1, sorry 1 comma 1, what to add, addition rule will become 1 plus x comma 0, and it is never equal to 1 comma 1, right, it is never, because second coordinate here is 0, here it is 1, so this property fails. Additive inverse exists, okay, does not exist, जब identity ही नहीं है, so how to check inverse, right, so
Okay.
this is
This one is true.
does not exist. So question was about incorrect statement, so third is incorrect, everyone understood, right,
Sir, 1 minute.
okay,
Sir, identity is 0, 0.
0, 0, sir. Additive identity is 0, comma 0.
okay, let's say we are adding to this, what we should
Additive
get,
identity is 0, 0, 0. Exist, but the inverse does not exist.
okay,
Inverse does not exist is the correct incorrect statement. Inverse is also exist.
okay, here you should look here, here I'm writing something, 1 comma 1 plus 0 0, what we should get, 1 comma 1, right, sorry, because this you are saying this is identity, है ना,
Oh, okay, okay, okay.
but what our rule says, rule we have defined plus here, rule says this will become 1 plus 0 comma 0, and it will become 1 comma 0, but these two are never equal, I said here,
Okay, sir, clear.
clear,
Okay.
so identity does not exist, I said even
Oh,
कि you can take any xy, that xy will not be identity, and proof is here, ठीक है, so we are going to see next question. Which of the following statement is correct? Set of all Hermitian matrices from subspace of n cross n matrices over C with respect to standard addition and scalar multiplication. Okay, first of all, n cross n matrices are denoted by n cross n. Entries are from F. F can be C or real numbers or complex number or whatever, any field. This is collection of n cross n matrices A11, ANN, square matrices. Aij belongs to F. This is vector space, right? इसमें कोई डाउट है क्या कि ये वेक्टर स्पेस है या नहीं? What is addition here? Any Aij adding some matrix Bij of same order. Okay, same order matters here. What is definition? Coordinate wise, Aij added to Bij. And scalar multiplication was any matrix we multiply C, it will go to coordinate wise. Means every entry will multiply by C. Okay. To mention order, you should write n cross n everywhere. Otherwise, if you understand, then it is okay. So these two operations, this set mn n cross n, some people also write mnf. These two are same thing. So this is vector space. Okay. You might have some doubt. Adding two matrices, we are getting third matrix of same order. This is also in an MNF. Multiplying, this is also in MNF. Associativity holds here because associativity holds for fields coordinate wise. पहले ऐड कर लो, देन कोऑर्डिनेट वाइज ब्रैकेट चले जाएंगे छोटे छोटे, वहां पर एसोसिएटिविटी लगा लो, फिर से ब्रेक कर दो. Sorry, how to explain? If everyone knows MNF is a vector space, then I can go ahead with these questions. Let me see. I suppose it is clear that it is a vector space. No one has doubt here. Okay, so what Hermitian matrices means? Hermitian matrices means A transpose and then conjugate. We will get A only. Somewhere it is also mentioned like A star equal to A. This sorry. क्या ये सेट ऑफ हर्मिशियन मैट्रिसेस सभी शेष फॉर्म करेगा क्या? हाँ, कोई बोल सकता है MNF वेक्टर स्पेस है, क्लियर है?
Yes, sir.
Yes, sir.
So we are going to show if okay. और स्क्रीन दिख रहा है ना मेरा?
Yes, sir.
Okay, good. Set of all Hermitian matrices does not form vector space. Why? स्केलर ओवरसी देख रहे हैं ना, ओवरसी, तो स्केलर मल्टीप्लिकेशन में
Scalar
इसमें
multiplication.
आई भी हो सकता है,
No.
आई भी एक स्केलर ही है. When we multiply a by I, it should belongs to, let's say, set of this set we are denoting S. It should belongs to S, correct? For every a belonging to S. इसको चेक करते हैं. ठीक है, a belonging to S है, इसका मीनिंग क्या है कि a स्टार इज इक्वल टू a. तो हमें चेक करना है आई ए स्टार, ये भी आई ए आ रहा है कि नहीं, करेक्ट? अगर ये होल्ड कर रहा है देन इट इज ओके, मतलब आई ए आल्सो बिलोंग्स टू यस, राइट? तो लेकिन चलो देखते हैं ए स्टार मतलब यहाँ पर इसकी वैल्यू क्या आ रही है. आई विल बिकम माइनस आई, क्योंकि कॉन्जुगेट लगा रहे हैं ना, और ए
IA star equal to minus IA.
हाँ करेक्ट करेक्ट, और दिस इज नॉट इक्वल टू दिस, सो दिस इम्प्लाइज कि आई ए इज नॉट नेसेसरली हर्मिशियन, जबकि ए था, ए वाज हर्मिशियन मैट्रिक्स, बट आई ए इज नॉट हर्मिशियन बिकॉज आई ए का जब स्टार किया तो हमें आई ए नहीं मिल रहा है, हमें क्या मिल रहा है, माइनस आई ए. ओके ओके, सो फर्स्ट इज इनकरेक्ट, so we have to see which one is correct. Set of all Hermitian matrices over C
Over.
is from subspace of increment matrices. Oh. Set of all
Correct.
Hermitian matrices over C. Let's say we are again denoting by S. Okay. Then S is not subset of M in R. क्योंकि S का एंट्री तो ओवर C है ना, ओवर C. और यहाँ पर MNR में क्या है, MNR में तो एंट्रीज कहाँ से है मैट्रिक्स की, रियल नंबर से. So, यस तो इसका सबसेट भी नहीं होगा, करेक्ट? तो सब स्पेस चेक करने की जरूरत ही नहीं है. वी डोंट नीड टू चेक दैट एस इज सब स्पेस बिकॉज एस इज नॉट सबसेट ऑफ MNR, राइट? अंडरस्टूड ना? So this is also wrong. N complex Hermitian matrices, entries are from complex, remember, does not form a vector space over real number with respect to standard multiplication, scalar multiplication, and all this. See, what was problemful here? When we are taking, yeah, here we don't have problem. A plus B conjugate, it will become A conjugate plus B conjugate, because transpose is also linear and conjugation, that is also linear, and it will become A plus B. So A plus B closed under addition तो था, already था, this was, but scalar multiplication में A fail कर गया. A was failed in scalar multiplication. See here, we are multiplying by IA and we are conjugate is getting minus I, which is not equal to I. So only scalar multiplication was problemful. But now if you see C is from real number scalar, now you transgate it, what you will get, C only, and here it will be transgate and it will become CA, right? So this is correct. This is a vector subspace, right? But oh, here it said does not, because of this does not की वजह से गलत हो गया. फिर वरना वेक्टर स्पेस तो बना लिया था. बिकॉज सी सेट ऑफ ऑल मैट्रिसेस में एसोसिएटिविटी वगैरह ऑलरेडी वेरीफाइड है। 0 इज आल्सो हर्मिशियन मैट्रिक्स, इसलिए आइडेंटिटी भी है उधर। माइनस माइनस से इनवर्स होगा एडजेक्टिव का। सारी प्रॉपर्टीज वेरीफाइड थे, ओनली प्रॉपर्टीज वर कि क्लोज्ड अंडर रिडसन और क्लोज्ड अंडर स्केलर मैट्रिक्स। तो ये वेक्टर स्पेस था, बट डज नॉट की वजह से गलत, ठीक है, ये सही होना चाहिए। सेट ऑफ ऑल हर्मिशियन मैट्रिसेस डज नॉट फॉर्म सबस्पेस ऑफ n क्रॉस n मैट्रिसेस ओवर C with respect to standard. This is correct. Does not form vector space because स्केलर मल्टीप्लिकेशन के अंडर में क्लोज्ड नहीं, बिकॉज डज नॉट है ना यहाँ पे, बिकॉज ऑफ दैट दिस ऑप्शन इज ट्रू। ओके, सेट ऑफ ऑल हर्मिशियन मैट्रिसेस डज नॉट फॉर्म वेक्टर सबस्पेस, सही है, क्योंकि दिस इज नॉट क्लोज्ड अंडर स्केलर मल्टीप्लिकेशन। We are going to see next question. F is a subfield of real number, sorry, complex number, and alpha 1, alpha 2, alpha 3 are three vectors. W base subspace is spanned by these three vectors. Which of the following vector is in W? So some vector V is in W if V is some linear combination of this alpha i's, sorry, मतलब lambda 1 alpha 1 plus lambda 2 alpha 2 plus lambda 3 alpha 3 for some lambda 1 lambda 2 lambda 3. If and only if even, I should say, because W is subspace spanned by alpha 1 alpha 2 xi alpha I xi belongs to C. So this is a set of all linear combination. Okay, good. चेक करते हैं। We want first coordinate to be 1, so अल्फा में तो 1 का ही मल्टीप्लाई करना पड़ेगा। We want last coordinate to be 1, so इसमें से तो कुछ शेयर कर नहीं रहा, so we want multiply here also by 1. Okay, इसमें कुछ मल्टीप्लाई करेंगे। हाँ, इसमें इस वाली लाइन पे देखिए, थर्ड वी वांट 3 हियर, सो इसमें तो 3 का ही मल्टीप्लाई करना पड़ेगा, तभी जोड़ जो है इन तीनों को पॉसिबल बनेगा। बट इन सबको अब जोड़ने पर क्या आ रहा है, 1 4 3 5 1, यहाँ पर ये मैच कर गया, यहाँ पर मैच कर गया, यहाँ मैच कर गया, लेकिन यहाँ पर मैच नहीं किया, तो दिस इज नॉट इन स्पैन। ओके, इधर फर्स्ट कोऑर्डिनेट में हमें 1 चाहिए, लास्ट कोऑर्डिनेट में 2 चाहिए, तो यहाँ पर 1 मल्टीप्लाई करना पड़ेगा, क्योंकि फर्स्ट कोऑर्डिनेट में जो भी शेयर मिल रहा है यहीं से मिल रहा है, इनमें से कुछ नहीं आएगा, तो लास्ट में 2 से मल्टीप्लाई करना
सर
पड़ेगा। हाँ,
सॉरी टू डिस्टर्ब, बट आपने 3 और 1 से मल्टीप्लाई क्यों किया?
ओके, लेट मी डू इट अगेन। तो हमें चेक करना है कि इफ दिस वेक्टर बिलोंग्स टू W और नॉट। अगर बिलोंग करना है तो इन सबके अल्फा 1 अल्फा 2 अल्फा 3 के लीनियर कॉम्बिनेशन से बनना चाहिए। ओके, सो हियर फर्स्ट कोऑर्डिनेट इज 1 और इधर फर्स्ट कोऑर्डिनेट 0 है, इधर 0 है, तो फर्स्ट कोऑर्डिनेट में अगर 1 चाहिए, इफ वी वांट 1 in first coordinate, so we should multiply by 1 here, then only the linear combination this. Okay, x1 alpha 1 plus x2 alpha 2 plus x3 alpha 3, sorry, x3 alpha 3 will become first coordinate पे 1, first coordinate पे if we want 1, so we should multiply 1 here, right, because others are 0, They will not share anything in first coordinate. And last coordinate also 1. Last coordinate here we should multiply by 1 here in alpha 3 because nothing is shared from these two zeros, right? Okay. And in the middle, this is 3. And here in the middle, this is 1. Everything else is 0. These are zeros. They do not share anything. So we should multiply 3 to get in the middle 3. This 3. Right? So other entries are fixed. This. So what it becomes? 1, 4, 3, 5, 1. यहाँ पर हम लोग 1, 3 दिस 3 एंट्रीज इन तीनों को पाने के लिए हमने स्केलर मल्टीप्लाई किया बट these are fixed, so this is not in the W. Similarly, in the second we want to multiply by -1 here because we want to get -1 in the first coordinate, and लास्ट में तो दो चाहिए तो हमें यहाँ 2 से मल्टीप्लाई करना पड़ेगा कि here only we have 1. अभी सेंटर पे हमको क्या चाहिए 2, तो यहाँ पर 2 से मल्टीप्लाई करना पड़ेगा, बट ऐड करते हैं तो क्या आएगा -1 -4 2, it will become 0 and it will become 2. Okay, here we have 10, right? Because of this 10, this is also wrong, not matching with this. This is for A, this is for B. We want to match these 3 things and everything should be matched, all 5 coordinates. Okay, next, this is I'm just trying my way. This is some not a I don't know how to solve this, but this is how I solve this. So in the first coordinate we want 1 in these both things. So first coordinate this should be multiplied by 1. Last coordinate also we want 1. So here I want to multiply by 1. And for this, let's say for this, we solve first this. We want in the center 4. So we want multiply by 4 here. Now addition of all this will be 1 in the first coordinate, 4 in the second coordinate, then again 4, then 9. There's 4 into 8. Oh, sorry, 10. And last entry is 1. So we are fixing these 3 things and everything else is fixed. So this is matching, not matching. This is also wrong. Okay, let's say we want to see choice for C, and the third one. Sorry, last one. My mistake. It should be correct answer. Let's say we want in first coordinate we want 1, so we should multiply 1. Last coordinate we want 1. Sorry. In the middle we want 2, so we should multiply by 2 here. You know why I am multiplying by 2? Because here it is 0 and everything whatever after linear combination we will take in the third coordinate, what जो भी मिलेगा यहीं से मिलेगा अल्फा 2 में मल्टीप्लाई करने से. Whatever you multiply in alpha 1 and alpha 3, nothing is going to change in third coordinate. Third coordinate we want 1, sorry, we want here 2, so we should multiply by 2. Okay, so what we are getting, the number 1, 4, 2, 2 दूना 4, 2 6, 1. This last one is correct. Understood?
Yes, yes, sir.
Okay, good. बहुत मेहनत करनी पड़ी. We are going to see next question. I suppose everyone understood. हाँ, we have 10 questions. I will finish in 8 minutes. जल्दी से. All f, so V is vector space of real valued functions from R to R. R to R function is real valued anyway. Nothing to worry. With operations point-wise addition and point-wise scalar multiplication. मतलब if we have two function f comma g, means R to R, f plus g कैसे define हो रहा है? This is also function, but while evaluating at any x, we should evaluate like fx plus gx. And c into f is also a function. This is function which after evaluating at x will become c into fx. These two are operations in the function space. V is collection of, sorry, V is equal to f from R to R. ये सारे फंक्शंस का कलेक्शन है और इनमें फंक्शंस का एक्शन भी डिफाइन है ऐसे कोऑर्डिनेट वाइज करके. ओके, सो फॉर ऑल ए, सो ऑल एफ सच दैट 0 पर जो वैल्यू ले रहा है 1 पर वैल्यू ले रहा है सेम होना चाहिए. सो लेट्स सी क्लोज अंडर एडिशन है या नहीं वो देखेंगे. ए नंबर f0 इज इक्वल टू f1 और g0 इज इक्वल टू g1. ये दोनों v में है तो इस कंडीशन को सेटिस्फाई करेंगे. नाउ वी वांट टू सी अबाउट f प्लस g. 0 पर इवेलुएट करें. इज दिस इक्वल f plus g at 1? Is this equal? By definition this is
Yes.
f0 plus g0 and this is f1 plus g1 and these two are equal. तो मतलब this set is closed under addition. ठीक है. Under multiplication c into f of 0 मतलब c cf of 0 is equal to this is equal to cf
Def of
of
1.
f1 because f0 is equal to f1 but this is equal to cf of 1. So cf at 0 is cf at 1. So close under dot मतलब star I should say. This is star. Okay. Okay. So first one is subspace. What about second one? F at minus 1 is equal to 0. Let's say g also minus 1 is equal to 0. So f plus g भी क्या होगा? Minus 1 पर. F of minus 1 plus g of minus 1 and it will become 0 plus 0 is equal to 0. Good. F plus g also belongs to V. What about c dot c star g or c star f anyway? It will become c dot, if we evaluate at minus 1 it will become c dot g minus 1, but g minus 1 is 0, so this is 0 and c dot g 0 is equal to 0. This is true in real numbers. These both are from real numbers, so multiplication up to means multiplication by 0 is equal to 0. So we are again in the good shape. So this is also subspace. Okay, what about c? Okay, let's say f and g are two functions satisfying the same condition. What about f plus g? We should evaluate at 3. We should get 1 plus f plus g at minus 5. Correct? What about this f3 plus g3 equal to 1 plus f minus 5, f at minus 5 plus g at minus 5. हमें ये चेक करना है. Is this true? Is this true? f3 is equal to क्या है? f3 is equal to 1 minus f5 means F3 get cancelled with this. Is G3 equal to G minus 5? No. Why? G was function in V and G was satisfying this condition. Means G3 is equal to 1 minus 1 plus G minus 5. ये कंडीशन जो सेटिस्फाई कर रहा है अगर G, तो G कैन नॉट सेटिस्फाई this is not equal. Okay, so whenever F and G are D is the correct option. This is true. D is the answer. Why? Let's say F belongs to B. Indicate if F belongs to B. What about 2F? Is 2F also member of B? Question mark is there. But question mark. No. Why? Because 2F of X square is equal to 2F of X square. But 2F of X square becomes Fx whole square, right? And this is not equal to 2F X whole square. So these two are not equal. So this implies 2F does not satisfy the criteria, this criteria. That is why it is not closed under its clear multiplication. Okay. तो उसमें आप देख लेना, मैं इसको अच्छे से लिख दूंगा थोड़ा सा, सेम चीज नहीं सेंड करूंगा, मतलब अभी तुम देख
Sir, 10th question, please show 10th question, sir.
10th question, yes, last question. ये set of all matrices which are invertible, इसमें zero matrix does not, zero does not belongs to, let's say this is W1, this is W2, W3, W4, W1 में zero नहीं है, so we do not have identity element under addition, correct? So this is not a subspace. All A such that A is non-invertible. Okay, इसमें देखो ऐसा कुछ ले लो, this is not invertible ना, this belongs to W2. For example, let's say 2 cross 2 matrix. And this also 0 1 0 0, this also belongs to W2 because for this is particular n equal to 2 I'm taking. But when you add these two things, if you add this, let's say this is x, this is y, what will be x plus y? This will become 1 1 0, and this is invertible. So this does not belong to W2 because W2 has property what? Every element is non-invertible. These two were non-invertible, but after adding them, we got something which is invertible. This is invertible, correct? So this is also not a subspace. It's not closed under itself. Not closed under itself. ठीक है. We'll go to see third one. Okay, let's see fourth one. Fourth one is also failing. How? If you have a square is equal to a, b square is equal to b, what about a plus b? Is a plus b whole square is equal to a plus b? Is question mark? No. It will be a square plus b square plus ab plus ba, correct? This. But a square, we can use these equations. So we'll get a and this will become b. But this extra term may not vanish. So AB plus BA, and this may not be equal to B A plus B. So fourth option is also failing. So third option should be correct. I can see it. Okay. Okay. Let me do it. B is a fixed matrix. Fixed matrix. B is commuting with A. Collection of all A such that B is commuting with A. ठीक है. So let's say A, A1 or A2 belongs to W4. What property they satisfy? A1 B is equal to BA1. A2 B is equal to BA2. So what about A plus A1 plus A2? Multiply by B. Let's see. It will become A1B plus A2B. This is first rule. We can multiply them. You can see ordering n cross n. That is why we are in good shape. If they are in m cross n, we cannot multiply them. Okay. So here we can multiply. Okay. So it will become BA1 because of this, and this will become BA2, and now we can take B common. So अंदर ये बचता है. So A1 plus A2 also commutes with B. So this is a subspace. Okay. So thank you everyone. So ये video will be available on YouTube and you will get link. I suppose NPTEL team will send to you, and the PDF will be available to you, and I will write them in proper manner because this is totally unreadable. Okay, so let me end this PDF. If you have some doubt, you can ask.
Thank you, sir.
Welcome. Okay, bye bye everyone.
Sir, is the final test based on these assignments?
Um, I don't know, but this will be, of course, solving assignments will be helpful.
Okay.
Similar question will be asked also, I think.
Some
So
more questions for practice.
we asked any theorems.
What?
So will we need to learn any theorems for the exam?
Theorems will be, of course, means if you solve exercises, theorem will be helpful, but they will not ask prove this theorem, prove that theorem. This will not be asked, I think, because अभी तो हम लोग ये सिर्फ देखेंगे कि आप थ्योरम को समझ गए हैं और उसका यूज करके एक्सरसाइज सॉल्व कर पा रहे हैं या नहीं. दैट्स ऑल.
सर वो फाइनल
Some
टेस्ट
more
में भी
questions for
एमसीक्यू है.
practice.
थ्योरम का स्टेटमेंट तो याद रहना चाहिए, बिकॉज इफ यू डू सम एक्सरसाइजेस देन अप्लाइंग सेम थ्योरम अगेन एंड अगेन यू विल रियलाइज कि इट इज गुड टू रिमेम्बर. अपने आप हो जाता है वो. लीनियर अलजेब्रा में बहुत थ्योरम नहीं है बहुत बड़ी बड़ी, तो इजी है. अपने दो चार एक्सरसाइज सॉल्व करोगे किसी थ्योरम से रिलेटेड तो थ्योरम अपने आप आ जाएगा.
Sir, next class you give some more questions for practice.
नेक्स्ट क्लास
Give some more questions for practice. Assignment is just like
ओके. सो
you collect some questions and upload in there. Otherwise you can leave.
ठीक ठीक.
Sir, is the final test MCQ based?
आई डोंट थिंक सो. आधा
Okay.
एमसीक्यू होगा और आधा तो रिटन होगा, बिकॉज दे वांट टू सी हाउ मच यू लर्न.
Okay, sir.
ओके.
Thank you, sir.
Thank you, sir. Thank you.
Okay. Bye bye everyone.